Section 3.9, Multiplication of Fractions, Part 1. The main purpose of this section is to build a foundation for proportional reasoning. Proportional reasoning is used in many areas of mathematics, including ideas like percents and ratios. One way of understanding the multiplication of fractions is by working with parts of a whole. Example, compute 1/2 times 1/3 using parts of a whole. The idea of this problem is that we want 1/2 of 1/3. So we begin by drawing 1/3, by drawing a circle and cutting it into 3 equal parts, and shading one of those parts in. What we want to do with this is we want half of the shaded part. So what we'll do is we'll start with the 1/3 portion that's been shaded in, and take half of that. So now the question is, how much of a circle do we have shaded in? In order to find out, we need to put this back in the context of the full circle. So you have these 2 empty parts, here and here. However, all the pieces are not the same size, and that's not just because I've drawn them poorly. Each of these, in order to be the same size, needs to be cut in half. So now the question is, how much of a whole circle is shaded in? There are 1, 2, 3, 4, 5, 6 parts of the circle, and one of them is shaded in. So 1/2 times 1/3 is 1/6. Example, compute 2/3 times 3/4 using parts of a whole. Again, this is 2/3 of 3/4, so we begin by thinking about 3/4. 1/4, 2/4, 3/4. And we want 2/3 of this. So what we will do is we'll take each shaded in wedge and cut it into 3 parts and shade in 2 of them. So these are the 3 shaded in wedges, and we're going to cut them into thirds. And on each wedge, shade in 2 out of 3. 1, 2 out of 3, 1, 2 out of 3, 1, 2 out of 3. And so now the question is, how much of a whole circle do we have shaded in? Well, we need to draw in this final wedge and cut it into pieces the same way as everyone else, and now we count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 pieces. How many of them are shaded in? 1, 2, 3, 4, 5, 6. So in all, we have 12 pieces with 6 of them shaded in. 2/3 times 3/4 is equal to 6/12. But 6/12 reduces to 1/2. Many students find this difficult at first, but after thinking it through a couple times, they find it's actually rather simple. Section 3.10, Multiplication of Fractions. Algebraically, multiplication of fractions goes straight across. This means you multiply the numerators and you multiply the denominators together. Example, compute 1/2 times 3/4. 1/2 times 3/4. We multiply the numerators together, and we multiply the denominators together. This is where the language straight across comes from. 1 times 3 is 3, and 2 times 4 is 8. 1/2 times 3/4 is 3/8. It's helpful to learn the connection between the picture and the calculation. 1/2 times 3/4 is half of 3/4. So we begin with a picture of 3/4, have a circle, cut into 4 pieces, and we shade 3 of them in. Then what we did is we took each shaded piece and took half of it. One out of 2, 1 out of 2, 1 out of 2. Then we needed to determine how many pieces total there would be in order for all these pieces to be the same size. So when we think about multiplying straight across, where do each of these pieces come from? Well, the total number of pieces, 2 times 4, comes from the fact that we started with 4 pieces and we cut each in half. Cut into 2. This leads to 8 total pieces. So now let's think about the numerator. We started with 3 shaded pieces, and each piece turns into 1 shaded piece. This gives us a total of 3 shaded pieces. Example, compute 3/4 times 2/5. 3/4 times 2/5. We multiply straight across. 3 times 2 over 4 times 5. 6 over 20, and this happens to reduce to 3/10. Now, if you're familiar with reducing before multiplying, that's okay. I'm not going to demonstrate it here, but it is something that many people know how to do, and it's not wrong, although it can be very messy if you're not careful with your writing. Example, compute 6 times 2/9. Just as before, the trick when working with integers is to rewrite the integer over 1. 6 times 2/9 is 6 over 1 times 2 over 9, and now we can multiply straight across. 12/9 happens to reduce. 3 goes into both 12 and 9, leaving you with 4/3.